Thank you. Yep, my name is Sarah Bird. You can find me on the internet at @birdsarah. I was just saying, the more I talk, the more I seem to get increasingly nervous, so I am melting on the inside. So if I make mistakes, please forgive me, and please feel free to shout out if you see something insane. I'm a research and experiments engineer at Mozilla. It's a position I joined just a few months ago at the beginning of March. My life was a happier, more innocent life before I joined Mozilla. As mentioned, I'm also a core maintainer of Bokeh. I must confess I haven't contributed any code in a while, and I hope to get back to being more active in the community. So I don't want to wear that label too loud, but I am a huge fan of Bokeh, and you will see a bunch of Bokeh in this presentation today. It is, objectively speaking, the world's best plotting library. All of the slides are up on my GitHub. A few quick public service announcements. Mozilla, we make Firefox. Most people know that. And yay, Firefox. And we make... and we make lots of other cool things too. I've been surprised since I joined and spoken to my friends about joining Mozilla that a lot of people don't know that we're a non-profit, so I just want to say it again. Hopefully this crowd all knows that. We're a non-profit, and our mission is a healthy internet. My other public service announcement is for the NumFocus, the amazing organization NumFocus, which incubates all of those projects on the left and is affiliated with the ones on the right, and helps with the PyData conferences. And there are 2 PyData tracks here, and it's an amazing part of the Python ecosystem now. So I just want to give credit to the amazing organization and work of NumFocus. And today, we're just going to see a small fraction of that universe. We're going to be putting to use some Jupyter. Everything that you're seeing is running in Jupyter notebooks, pandas, Bokeh, the world's best data visualization library, Dask, scikit-learn, a little bit of PySpark and NetworkX in the background, and a shout out to Conda and NumPy, because you won't see either of them, but they are those core technologies that are underlying this whole ecosystem, and we would be nowhere without them. So I always like to give them a little bit of recognition. The web is terrifying. There are unseeing eyes all over. Oh, I just lost a... There we go. There are eyes all over the internet watching us whenever... the monitor here is blinking on and off if somebody knows how to make that not happen. The unseeing eyes that are following us all around the internet. So how does that happen? How are we followed around? How many people here have heard of a cookie? Good. It is, as we all know, a small piece of data that a server sends to a user's web browser. The browser may store it and send it back. It is a very simple piece of data. It's a key and a value. They say that naming things is hard. I like the name temp persistent user ID. And it's a... Sorry, sound man. And it's affiliated with a domain, in this case, the Haaretz website. So let's take a look at, oh my goodness, at, it's going to get tricky. Everything is flashing on and off and on and off. Okay, so first, you need to find your Firefox profile directory. I've included all of the code for this in the GitHub repo, but I have not included my Firefox profile directory because it includes an incredible amount of personal and sensitive information. So find your own and replace it. So once you know your profile directory, you can use Glorious Python to list out the contents of that directory and see a bunch of SQLite databases in that directory. I'm going to just look at this screen for now. Apologies for not facing you, but it's chaos over here. Great. Next we can use pandas, and we can use built-in Python's built-in SQLite to open the SQLite database and have a look at what tables are in that database. And then now we know the name of that table, we can use pandas and just read straight in from that table. And we're just going to take out for now just the domains that have set cookies and the timestamps when they were made. So this was a real profile that I was running on my work laptop. And I've just cut it off for the sake of this talk for 3 months, from March 1st, shortly after I joined Mozilla, to the beginning of June. Does anybody want to shout out a guess at how many cookies were lurking around after 3 months?
3 million.
It is definitely somewhere between 1,000 and 3 million. The answer was 3,000. And let's take a look at this with the world's best plotting library, Bokeh. This is, I'm not going to show a lot of Bokeh code, but this is what a typical piece of Bokeh code would look like. You set up a figure, you set up your data source, you can pass in a whole pandas data frame if you want, and then you start drawing things, patches and circles in this case, and configure it, and you get out something like this. And these are my cookies over that's my cookie count over that 3-month period. Now, does anybody want to hazard a guess what happened around May 1st? Say that again? I don't think any of the above. I decided to sacrifice my privacy at the altar of giving a talk and turn back on third-party cookies. So the first thing I'd done when I got my laptop was turn them off, and I thought, well, I'm giving a talk about tracking technologies. How bad can it be? Turns out, terrible. And so, yeah, so one of the other reasons that I kept this to a 3-month window is because once I put this talk together, I was like, this is horrible, and I started a fresh profile. So I'm no longer using this profile on my machine. So we can use some straightforward pandas to just have a look at the domains that were setting cookies. 60 cookies over 3 months is like one every 1.5 days, give or take. And although I look like the kind of project person that might go to Insight Express AI and stickyads.tv.com, I haven't actually been to those websites, and I don't know what they are. So we can use, there's lots of great ad blocking companies and open source softwares out there. Disconnect Me provides a list that categorizes domains for us into some useful buckets. And so we can merge that on, and we can see that most of those high count ones that I don't recognize, unsurprisingly, are advertising domains. And we can sum them all up, and we can see about 20% of the cookies that were set, probably mostly in that last month, were advertising and analytics cookies. But a lot of those, were not categorized by the Disconnect Me list, and we can think about that a bit later. But there are lots of advertising companies out there. Maybe it's not too bad. So if we explode that group by a little bit, we can actually see that within advertising, there are a lot of different ad companies that have set one-off cookies. And so maybe that's not that bad. There's just all these different players out there trying to make a buck in the world, and maybe it's all okay. Cue evil laughter. I'd like to introduce you to 2 little scamps that I call Cookie Syncing and Zombie Cookie. And Cookie Syncing is sad because Zombie Cookie has a way cooler name. And together, they get together and destroy our privacy. So let's look at cookie syncing first. This is the process by which different trackers, different players, link IDs that they've given to the same user. Stephen Engelhardt wrote a really nice blog post about this back in 2014. Or you can just go and read Google's docs about it, because this is providing this. Google provides cookie syncing as a service, and it is really the backbone of the real-time bidding infrastructure that happens every time you get served ads online these days. But do we see this? Does this happen in practice on my machine as I'm going about my happy business? So we're going to take a really crude approach to looking at this. And we are going to start with our cookies database again. We have our domains, and this time I've pulled in the values that are actually in the cookies. And I'm going to do something really crude. And for every value in that list of 3,000 that I have set, I'm going to go and see if that value is in any other values. And then that's going to give me a filtered list, and then I'm going to aggregate by the domains, and I'm going to be super conservative and say that if I've got more than 5 domains that are appearing in here, I'm going to add it to like a shared value list. And then a little bit of futzing to get it down. I decided to keep the IDs to be more than length 10, and to not have com in them. And that quite quickly, very straightforward code, gave me a set of 25 potential IDs. And they definitely look like they could be unique identifiers. And so here we can see what that looks like. You can see that that string, the 7620423, is in the values, but it's not the exact value. And so can we see cookie syncing? Like, I'm a visual person, I'm a bokeh developer. Let's put this together. So let's use NetworkX to build up a graph. And we don't need to worry too much about the details of this. We're going to color the nodes of the graph. Each domain is going to be a node, and we're going to have edges every time they've shared an ID. And so we've colored the nodes by those disconnect categories, and we've colored the edges by ID. Some beautiful bokeh code, which I will skip, but bokeh plots graphs. And here we have it. And we're going to take a little minute to look at this. So we have this group over here. And these are all the Wikimedia companies. And so they've all shared some kind of ID, and they're all just off on their own there. They're in their own little group, and that is not tracking. That is a completely legitimate use of sharing an ID, and probably something that's quite useful and good internet behavior, and we shouldn't be too worried about it. And then we have this hot mess. And at the heart of these hot messes are things like Pubmatic, which was, if you remember, high in my list of cookies that have been set. And you can see all of the different colors coming out of there, which means that it is at the hub, and it knows about dozens of other different companies' identifiers. And it means that when companies can buy and sell data behind the scenes, they can then rejoin all of that data together because they all know about each other's IDs. And you see it over and over again. And you can also see on the edges of this, on the outsides of these networks, are websites that I've gone to, like Wired.com, LA Times is tucked in here somewhere, and they're companies that are participating and facilitating this ID sharing. But this is not a complete picture. That was a much smaller set of domains than are actually in this whole, they're in my whole cookie table, and I used a very crude metric for getting there. Maybe you can, I'm sure you can do better. Feel free to do better and let me know about it, because this is an interesting problem. But we can delete our cookies, right? Back to zombie cookie. So zombie cookies or ever cookies are cookies that are recreated after deletion, and they do that by storing the information that's in a cookie in lots of other places. And there are close to 20 other places that this information can be stored. But does this really happen? Oh, I can't see anything. So we're back with our Firefox profile. But this time, we're going to look at our local storage directory. And so in our local storage, we read it in the same way. And very similarly, we see key-value pairs associated with a domain, but it's now local storage. And we have our 20-something IDs that we got from our cookie table. And now we're going to go and look for those. And we find that one of those IDs from the cookie table has been stored in our local storage. And so an idea occurs to me. Can I bring a cookie back from the dead? Can I raise a zombie cookie of my own? So I created a completely fresh profile, and all I did was copy across the local storage SQLite database, nothing else. It was a completely clean profile. And then I went to the LA Times, which I might add I pay a subscription to, which makes it even more irksome. We're in our new profile, completely clean. We open it up, and the very first time you create a profile, there are just 8 cookies in there. And then we go to the LA Times. And we've copied across the local storage. And now what we want to see is, did that cookie value from our old profile, did it appear in our new cookie database? And the answer is no. Hooray, privacy not invaded. Although I must admit to being a little bit disappointed, because obviously I'm writing a talk about tracking technologies, and if it had worked, it would have been cool. But then I'm suspicious and untrustworthy, and I thought, well, I haven't actually clicked on a story yet. So then I clicked on a story, and there it was. And as soon as that Taboola content populated, the Taboola JavaScript pulled that cookie back out of pulled that value back out of local storage, put it back in my cookie table, which means that all of those other third-party cookies are then going to go ahead, keep doing that cookie syncing, and now they have the means to link up. Even though you've completely wiped your cookies, they have the means to completely link back all of your data. Well, that's depressing. Okay. Sorry. Let me see. Nope. Oh, boy. Right, we're back. I wrote this in here because I kept getting lost. Okay, so cookies. A cookie is a small file placed on your device that enables features and functionality, which is a sort of paraphrase of your average corporate cookie policy. What they typically miss out is the second part of that sentence, which is, and enables us and others we enable to completely compile your entire browsing history. Do you care? I know I do. I feel uncomfortable with the level of sharing the domains I visited already, when you start to think about adding that together with all of the stuff you do on your mobile phone, your location, your smart TV going, your smart fridge, drones, whoever knows what, when that data gets stolen, or when you start to be discriminated against or paying more for services because of this data being known about you. And your browsing history can be and is connected to your real-world identity. Has anybody here never used social media? Daniel, my hero. I don't know if Daniel's lying or not, but Richard Stallman certainly hasn't. When we do that, we create a very, very straightforward way to link our online behaviors and our offline behaviors. But even if we weren't, there is a whole industry called identity resolution, which back in those happy days of January 2018, I had never heard of. Axiom, I'm not picking on them. They're just one of many, many companies that do this. They do about $1 billion a year in revenue, and they employ what they call privacy-compliant matching, which I read as legally compliant privacy invasion, where they take your digital identity, your online identity, and they map it across all of the different devices you're on, and then they connect that up with your offline identity, and then they proudly sell to marketers an addressable base of 2.5 billion people. I don't know how much of that is true, but they're certainly worth a lot of money. Fine, you'll turn off cookies. You will never, ever, you'll type a password every time you go to a website. You're never going to use cookies again. But it's really your browsing history that is giving up your identity. So is anything else giving up our browsing history? The language we all love to hate, JavaScript. And so there are also lots of other things, web beacons, your ISP, but we do not have time to go into that today. I'm going to tell you a little bit now about a project that my team at Mozilla, the Systems Research Group, has been doing. We have Martin and Dave on the left, if you can't tell them by their photos. I used to think they were paranoid, and now I realize that they are the smart ones of my team. It's very hard to find them online. In November 2017, before I joined the team, they ran a crawl, visited 1 million locations, and recorded 131 million JavaScript calls. So they went to 1 million websites, and they'd set up an instrumented web browser to record a whole series of JavaScript calls that are typically associated with tracking behavior. Oh. Okay, I will go fast. You can read some of the results at hacks.mozilla.org, which is where we had some students look at this data and start digging into it. What this data looks like is not too complicated. For every line in this 131 million data set, we have the location we visited, the location of the script that was loaded, some other things, and of interest for today, the JavaScript API interface that we hit, so something like window.navigator.useragent. I'm going to skip over my first aha moment in the interest of time, but the TLDR is I realized that when you go to a website and you see it load a few little scripts, you don't think too much of it. But if you look at that from the other direction and you play the server and you see the breadth of websites that a single script server can see, you start to see the reach that they have into an ecosystem and when you, into your traversal of the internet. And when you combine that with behavior, things like cookie syncing and these other things, you can see how people can build a really complete picture. And I would totally recommend going to panopticlick.eff.org. They have been shouting about this being a problem since at least 2010, and you can see how unique your web browser is. And we're just going to look at one example of the kind of fingerprinting that you can do with JavaScript called canvas fingerprinting. And there's a well-known open source library called Fingerprint2 that's available online. And we're going to have a look in our data set at this and see if we can see this in action. And so this is now using Dask because this data set of 131 million lines of calls is about 75 gig of data compressed, so it gets really big. And so we're going to use Dask, which gives us a very pandas data frame-like API, but handles it out of core or in a distributed system. So we're just going to read in a few columns. In particular, we're interested in the symbol column. And within that, we're interested in the fill text. The fill text, which is one way we can see what's happening in Canvas fingerprinting. And that'll be, I'm going to go fast. But you can see this is a very pandas-like API, but it's running out of core to filter that data set for us. And here are the results. And I'm just going to skip out of this and go down and zoom in a bit. And so here we are the kind of things that we're seeing in this data set of going to 1 million websites, the kind of things we're seeing people write to canvases. Canvas is the same technology that Bokeh uses to render visualizations. It's a great technology, it's a great web technology, and it's super useful. But rendering a smiley face, or this set of text, or the very cheeky Canvas fingerprinting is not being done to serve a useful purpose and to serve you content online. It's being done to track you. And that. Okay, so yes, this is really happening. We can see it in this data set. I have 1 minute remaining. I promised you some scikit-learn, and I'm going to skip to the end of this, which is just a very beautiful visualization that I made. And so what I started to do, coming back to that uncategorized list of, that uncategorized data before, we can go and look at existing tracking scripts and so on out there and say, okay, well, they're using this JavaScript API. Okay, well, we can start blocking that. But we're always going to be one step behind the people that are doing this. So what I want to start doing is, can we use clustering to sort of detect from crawls and from data that we have in Mozilla, can we see tracking and new tracking technologies coming to light and happening in real time? And so this is a project that I'm working on now. It's a work in progress. It doesn't work yet. Each of these are sort of different clusters of every little square on, every colored square on here is a different part of the JavaScript API, and they're colored by the different sort of flavors. The outside is like window.navigator. The inside colorful ones are sort of the audio APIs and so on. And so the thing I want to finish with is I'm hoping you can do better. And I want to let you know about that we have open sourced this data set, and it is available at the Overscripted Data Analysis Challenge on Mozilla's GitHub. And we have a competition running through the summer till to win prizes, to come and present your work at MozFest at the end of October. Tickets, airfare, all that is included. And if you are thinking about getting into data science or doing more analytics, or you're interested in tracking technologies, this is a really untapped data set that we would love to see what you can come up with to help us fight the good fight at Mozilla against tracking technologies. So thank you very much.
So thanks for this amazing task. I'm sure there are some questions.
Thanks for a great talk. So you said you turned on your third-party cookies?
Yes.
And then you turned them off again. Does that help? Is there any meaningful difference with them turned on and off?
I just started a fresh profile. I didn't, that would be an interesting thing to do. But what is one thing that's worth noting is that when I first ran that count of how long that data frame was at the beginning of June, it was actually like 3,700 cookies. I then subsequently opened that Firefox profile maybe a month later, and a bunch of those cookies expired, and that number went from 3,700 down to the 3,000 that we saw today. And so yes, some of those cookies were expiring. Whether it was the good guy cookies or the bad guy cookies is, I should find a gender-neutral term for that. Anybody can be evil. You know, I don't know, but that would be an interesting thing to do, to mess around with your own profile and see it happen.
Okay, thanks.
Thanks. Yeah.
Don't I? Thank you for the great talk. Do you know if the resource will be available later?
Say that again?
If the resource, like all your Jupyter notebooks and
yes,
all,
they're all available at Bird's EuroPython.
Okay. Thank you.
The code that runs, for example, the clustering analysis that I was showing at the end, that's not runnable code, but the stuff from the start and this overscripted data analysis challenge repository has a working get started with the data notebook in that I put together. And so if you have any issues with it, feel free to file issues or ping me on Twitter.
Thank you. Hi, thanks for the talk, very interesting. I wonder if you can talk a bit about the features, attributes that you have been using for the classification of the type of cookies.
For which type of cookies?
So, yeah, what features do you use to classify?
You mean like advertising content?
Yeah.
That I did at the start. So that was just using the disconnect me list, and so So this is sort of bringing together, sort of thinking about what I was doing at the end with the kind of, can we get ahead of the arms race and detect these things in more real time? A lot of ad blocking, in fact, as far as I know, all of the ad blockers that you could use, be they proprietary or open source today, I for the most part, using lists. Some smarter, some less smart, but they're using lists to say, block this, block this, block this, block this. And so it means that we're always playing catch up. And so what I want to try and do is see if we can detect sort of good JavaScript, the JavaScript that we want and that's desirable, and the JavaScript that we might perhaps consider undesirable, and sure we can put that choice in the hands of users, and then do some of that classification in more real time. But for the moment, the classifications you saw at the beginning of the talk are based on public lists that are out there from either AdBlock or Easy Privacy or Disconnect Me, or lists that you can find online.
Thanks for the great talk.
You're welcome,
one
Alex.
question, it's more or less related with that. What features did you use for this last plotting where you did the clustering?
Sure, I skipped over that. Well, I mean, if I feel like you're just giving me an opportunity to do the rest of my talk, I appreciate that.
That would have to be in 30 seconds, please.
Okay. Why have I got a blank screen of death? Oh, no. Well, there we go. I guess computer knows. I took the symbols, so like all of the JavaScript API calls, and I built together a kind of fingerprint for a given script on a given location. And I sort of just did ones and zeros. And so I ended up with every possible JavaScript API call became a feature in my, a machine learning feature, right? Became a column in that array. And then I was trying to do clustering based on those columns and looking for similar patterns.
Okay.
And I'll just add one thing. I did, the early reason I think that this is promising is I started to pick up things like, it was finding a cluster of Facebook and FBCDN. Now, it didn't know that those two domains are connected, like have a business relationship, but I was starting to see domains that I know have a business relationship with my human intelligence being picked out in these clusters. So I do think there's something there, although I have a lot of work to do on it.
Okay, so let's give a big hand to Sarah again.